Wetlands. Let's talk about wetlands. Where do they fit in the hydrologic cycle? Okay, they are surface water that is in direct contact with groundwater. So on this diagram, there's no wetlands. But here we have stream flow coming out of the mountains, and around freshwater and around saltwater, adjacent to those bodies of surface water, there's usually going to be some wetlands. So let's talk about how they fit into the ecosystem and the hydrology. Okay, so hydrologically, they have inflows and outflows. There's groundwater flowing in, GWI, groundwater flowing out, GWO. If the inflow exceeds the outflow, then the water level in a wetland, it will get deeper water. If outflow is exceeding inflow, then the water level is going to drop. Either way, the groundwater is usually right around the same elevation as the top of a wetland. There's also going to be surface water, not every wetland, but often surface water flowing in, SWI, and surface water flowing out. At the same time, there can be precipitation coming from the atmosphere down, and then also evaporation of water back into the atmosphere. So those are the inflows and the outflows of a groundwater. If we look at a cross section of a groundwater, the R's on here, those big capital R's at the top, that's recharge, that's precipitation coming in, and then D is discharge, so local discharge. So we have recharge of the groundwater system and discharge in these little wetland pockets. So local D, local D, local D, these are depressions where there would be a little pocket wetland on the surface. So this looks kind of like a complicated landscape, but this is typically what you'll see: rolling hills and local little pockets of groundwater flow into a little wetland area. And then R, that broader area at the bottom, is the regional system, the regional groundwater flow. Okay, what about these wetlands? Are they a nuisance? They're smelly, they smell like rotten stuff. They have alligators, there's bugs, snakes, mosquitoes. Maybe we think of them as vectors of disease and places where we could get eaten by an alligator. We want to rethink our perception of wetlands, though, and think about their importance in the ecosystem. It is true that in the United States, we haven't really done a great job of preserving wetlands. By the mid-1950s, over 50% of the wetlands in the United States were compromised, either by being put behind dams, maybe they were filled in for agriculture or for development, drained, farmed over, paved. There are big cities that are underlain by old wetland deposits or were filled in to make the cities. Washington, D.C., Philadelphia, New Orleans, San Francisco all sit on top of wetlands. In order to protect and discuss wetlands, it's always been important to think of what is the definition of a wetland. So we need to think of it in terms of the hydrology. What's the water doing? What's the vegetation type in that wetland? And what's the soil like? And those three come together to make the definition of a wetland. Let me read a little bit here. We'll go through some of the definitions. Ecosystems that are inundated, have water, or saturated by surface water or groundwater, all are part of the year, and the frequency and duration of that saturation support hydrophytes. Hydrophytes are plants, and they're plants that have adapted to have basically wet roots. If you have had a house plant and you overwater it and it dies, so that is not a hydrophyte. A hydrophyte is a plant that wants wet roots, and so those are special plants that have adapted to that kind of environment. The soil is unique too. The soil forms under conditions of saturation, flooding, or ponding long enough during the growing season to develop anaerobic conditions in the upper part. So the water isn't churned. It doesn't have a lot of oxygen in it in a wetland. And so the soils are going to develop in a place where there's not a lot of free oxygen. So in order for the federal government to regulate wetland and wetland development and wetland protection, here's the definition. Soil that in its undrained condition is saturated, flooded, or ponded long enough during a growing season to develop an anaerobic condition that supports the growth and regeneration of hydrophytic vegetation. So it takes those three things into account. All right, there are different kinds of wetlands. We're going to go through bogs, fens, swamps, and marshes. Bogs formed purely from precipitation. Fens are going to be maintained by groundwater. So that's our first designation, bogs and fens. In both cases, the underlying geology, so we have that water, we have the soil, now the geology underneath that environment matters because it doesn't allow, it holds that water in place. It doesn't allow for infiltration of the groundwater. So here's two examples. The top image is the Everglades of Florida, and the underlying geology there is limestone. So limestone, that bedrock geology, holds that water, keeps it from infiltrating and going too deep. It just keeps it ponding at the surface. The other example here is in Canada, right along the Canadian-US border, and those soils have formed 20,000 years ago during the last ice age and the melting of those glaciers, and it's the mix of grain sizes in that sediment that and clays and till that keep that water in place along the US-Canadian border. Okay, ducks. Ducks live in wetlands. So we're going to talk a little bit about the importance of wetlands. And this image talks about some of those, some of the reasons why we want to preserve a wetland. So let's look at those. Dissipates stream energy. So if you have a raging river coming in, the velocity is going to stop there at the wetland and the energy level is going to decrease. So we have dissipated that energy and the river is no longer going to be able to move such big grain sizes. Erosion stops. So dissipating energy is an important part of the job that wetlands play in the floodplain. Another is, let's go over here, bacteria break down contaminants. So there is bacteria in the wetland, good bacteria, that actually break down pollution. The sediment in a wetland, let's see, here it is. Contaminants and sediment are filtered. So contaminants get trapped in there with those clays, those fine-grained particles in a wetland, and then the bacteria break them down. So they're really like the liver of the ecosystem, breaking down and storing contaminants. Speaking of storage, the saturated peat stores water. So there's so much organic material in a wetland, it doesn't rot right away. It's anaerobic. That stores water. The wetland, it also provides critical wildlife habitat. Here's a pair of mallard ducks, but this is also nurseries for baby animals. If you were going to go find frog eggs, right? You want some frog eggs for whatever. You would show your kids baby frogs and tadpoles. You wouldn't go to a raging river to find that. You would go find a pocket of still water. So baby animals start out, and nesting pairs of different migratory birds all start out in these wetland environments. And then on the other end of that wetland, what comes out of it is going to be cleaner water. The wetland has trapped sediment. The wetland is dealing with the contaminants. That's back there in the wetland, so water coming out now is going to be cleaner. The wetland's been storing water, so floodwaters can be stored in the wetland, and then slowly that water is going to come out, this slow release of stored water. So where we have wetlands, the flooding is less. The magnitude and the frequency of flooding is less. Okay, let's look at the interaction. I know this is a black and white image. It looks kind of old, but I like the way it looks. These are 3 different settings for wetlands. So here is a depression in the topography, and this dotted line back here in each of these images, dots or tiny little dashes, is the water table. And the water table is what we call the top of the saturated zone. So we're going to have a chapter later on groundwater, and the top of the groundwater, the top of the saturated zone, is called the water table. Below the water table, all the pore space between grains, cracks, and rocks is all full of water. Okay, so this is dotted dashed line here is the top of the water table. And notice it just skims the surface here. That is a wetland in that pocket. In the next image, the water table intersects this hill slope, and that wetland then is kind of like forming at a spring. So the intersection of the slope and the wetland. And here again is kind of a perched wetland. So the water table comes in, hits this flat area, and then the water table then releases down into the subsurface, and maybe this black area here is a river. So this would be what you might see on a floodplain. So the floodplain deposits holding up that wetland, and then down here is the stream channel. So very close interaction between the water table and wetlands. All right, back to more wordy words about the importance here. So they're very productive terrestrial ecosystems. They're terrestrial and aquatic like at the same time. Rainforest is probably the only more productive ecosystem. What that just means, that productivity, there's abundance of plants and animals in that environment. But a third of threatened and endangered species in the United States are wetland species. We also can think of wetlands as a resource, fiber and food. Rice paddies, peat, mangrove swamps, cypress swamps, salt marshes. These are all areas where we can get resources. We eat food from the wetland, and we can get wood from the wetland. So it's a very much a place of resource. Buffers against seasonal flood. Remember, we can think of these wetlands as storing water. So seasonal floodwaters can be stored in wetlands. You know, maybe the water gets deeper, and then seasonally it's going to get shallower, just as that water table moves with the addition and subtraction of that seasonal rain, basically precipitation. We really can't forget about how much the wetlands can reduce pollution and hold contaminants and filter water. So they are holding in carbon, holding in nitrogen. They act as the part of a healthy riparian buffer zone would be pockets of wetlands. The riparian buffer zone, remember, is that vegetated corridor adjacent to a stream. So the floodplain and other areas next to a stream. Having a wetland area as part of that riparian buffer zone just makes it that more healthy for the ecosystem. And purified water then would come out of it. There are places, California, Maryland, Louisiana, I know they do this also in Japan, where they're using wetlands as one of the stages of sewage treatment. Certainly they're not like dumping raw sewage into a wetland, but they're using it as maybe one of the later stages in the filtration process. All right. We see wetlands again as a nuisance, so they have to be protected. There are people who just want to fill them in, and then there's no recourse to get those wetlands back. So since the 70s, internationally, they have really tried to have treaties to protect wetlands and really educate politicians and educate voters on the importance of wetlands. So there's an international treaty that acted to make a bold statement about the importance of wetlands, and that was in 1971. In 1972, then, a really big, important thing Congress did was bring about the Clean Water Act, and that was the first kind of protections for wetlands. And we'll look at the statement here. Permits are required before solid material can be discharged into navigable water. Wetlands we're including in that. This navigable water thing has been a problem with trying to protect areas like wetlands and small streams. Definitely recently, like with mountaintop removal in these southern states that have coal. So coal used to be something that they would mine down into the earth for, and now instead of doing that, they'll just blast a mountain away, and in blasting that mountain away, they expose the coal layers, but the blasted mountain from the top has to go somewhere. So they were taking and still are, the top of the mountain and filling in valleys, basically flattening West Virginia. So those kind of laws go back and forth. It just depends on what administration is in charge of Washington and changes in the Clean Water Act. Okay, that was in 1972. It continues to evolve. The Food Security Act in 1985, part of it, they're always tacking on things to laws, was protection of wetlands. Like, okay, you can grow this food and you can have these subsidies, but you've got to protect the wetland. And so they have gone back and forth with that. There's laws against destroying wetlands, and then incentives, more of these subsidies for farmers, as long as they'll protect the wetlands. So property owners can destroy wetlands in some cases, not all cases, but it can be done. And what usually there'll be a trade-off. If you're going to plow under this wetland, then you've got to create a new one somewhere. But remember that definition of wetland, you got to have a special soil. You've got to have a trap to trap that water. So it doesn't always work when they try to make a man-made wetland. So in this image here, they have filled in one place and there was a pond. They're like, oh, there's a pond. Let's just plant some reeds out there and we'll make a new wetland. So the hydrology is complex, and they do try to make and mimic the conditions that might be in a wetland. But there are ways around not protecting wetlands. All right, so we're going to talk now we talked about bogs and fens a little bit. This is about swamps and marshes, and the difference here is the kind of plants. So in a swamp, there are going to be trees. In a marsh, there's going to be grasses, soft stem vegetation. And marshes are either going to be tidal or non-tidal, like at the beach or not at the beach. My face. This is a swamp. So swamps have trees in them. There are different kinds. Red maple swamps are in the northeastern United States, and the southeastern part of the United States. They're out on the coastal plain. The soils are thick, black, and nutrient-rich. The trees in there have to be special kind of trees, these hydrophytic trees, cypress, Atlantic white cedar, and tupelo. There can be little shrubs, button bushes, smooth alder. Those grow adjacent to streams and certainly are fine having their roots wet. The organisms in these swamps are like stuff we eat. Oh, I guess we don't eat crocodiles. Oh, I think maybe we do. Alligators. Freshwater shrimp, crawfish, crawdads, clams, crocodiles, alligators. We eat all that. So they are places where we can get food. The mangrove swamps dominate southern Florida, and mangroves can grow either in salt and fresh water, and they grow at that interface between salt and fresh water. Okay. What is the importance of these? Whoops. of these swamps, sorry about that, they offer flood protection, so they hold a lot of water. You saw from those images, they're standing water. These swamps tend to be very, very, very wet. So they also have nutrient removal. Phosphorus and nitrogen gets washed into our waterways, and it gets extracted by these plants. And that's good, not to have too many nutrients in our waterways. The problem with too many nutrients is they, a couple steps later, can remove too much oxygen. So you'll get a problem with the amount of dissolved oxygen in our waterways. If we can sink those nutrients somewhere else, that's a good thing. They also have a high species diversity. Because the trees go so well there can be pretty good timber harvest, and I already mentioned we eat it. In South Florida, these mangrove swamps, like the image here, they are buffers against storms. It's been proven that when hurricanes, like the hurricane a couple years ago that hit the Keys, areas were way more protected when there was a healthy mangrove swamp off the coast. They trap sediment, all that inner network of roots that come off of mangroves. They hold sediment, and that really helps with shoreline erosion. Swamps have trees, marshes have soft, grassy areas. Marshes can either be tidal or non-tidal, so basically near the coast or not near the coast. They're important because they have fresh water in them, or a mix of fresh and salt water, and can recharge the groundwater. They also really act like a swamp does in sucking in nutrients. Those nutrients, nitrogen and phosphorus, if they're found in abundance and pollute fresh water, they create a eutrophic, which means lots of good healthy plants, too many plants environment. Eutrophication is not good. It means well fed is what it means. And so too many plants then die and then decay, and those plants, and the decay of those plants, like algal blooms, decreases the oxygen in the environment. So having marshes suck in those nutrients is a very good thing. They also moderate the stream flow. They slow streams down. And like other wetlands, they are going to store sediment and pollution. Let's look at the two kinds then. Non-tidal, these are going to be adjacent to... Why does it have to be right there? Adjacent to streams. So along streams and poorly drained depressions, or in the shallow water around ponds, lakes, and rivers. Non-tidal marshes can dry out completely, but generally range a few inches to about 3 feet of water. These areas can be very diverse, lots of different kinds of plants. I say grasses, but lily pads, cattails, reeds, and bulrushes. They also have a lively, not just flora, but fauna. Minks, otters, herons, muskrats, waterfowl. Definitely important for migratory birds. Prairie pothole marshes are the first kind. These are depressions in the landscape that have a base that is usually some kind of clay from glaciation, left over from the weathering of rocks through glaciation. And they are going to be filled with precipitation or snowmelt. So the water comes from above. 50% of the water, migratory waterfowl are going to stop by these prairie potholes in North America. Many of the prairie potholes are at the Canadian-U.S. border. I'll show you a map in a second. They absorb surges in rain, snowmelt, and floodwaters, so they reduce the risk of downstream flooding. And many of them are destroyed by agriculture. These are agricultural areas in the Midwest, North Dakota, South Dakota, Wisconsin, Minnesota. So these prairie potholes have to be protected. Here's a map. Let me move my face out of the way. Here's a map of the prairie pothole region. See, it just goes right along the Canadian-U.S. border. There are different parts to it, whether it's mostly mixed grasses, short grasses, tall grasses? Are there trees involved? So those are the regions of it. The first group of people who really realized that this area needed to be protected was duck hunters. They realized there was a decrease in ducks, and this is one of the reasons why the conservation group Ducks Unlimited was started, is because they realized the loss of the prairie pothole region. Here is a picture. I tried to match it up with the map. I think I did pretty good, of duck pairs per square mile. So there's the hot spots of ducks there in the red, and so lots of ducks. So Ducks Unlimited, the hunters of ducks, started to realize the loss of those mating pairs, and then that led to more conservation in the prairie pothole region. All right, another kind is a playa lake, and these are the prairie potholes up by the Canadian border, and the prairie potholes up here. As we go down towards Utah and Texas and New Mexico, Kansas, further to the south, Oklahoma, is where there are playa lakes, and these are ephemeral marshes. I've used that word ephemeral before. It means they're only going to be there when it rains. So these are short-lived. They are, though, the recharge region, the recharge areas for the Ogallala Aquifer. Here's that term, Ogallala Aquifer. They have a high biodiversity. In some areas, they're the only biodiversity because this whole area is dominated by agriculture. You have a playa lake that is the only thing that isn't soybeans or isn't corn or isn't wheat for miles and miles and miles. So the Ogallala Aquifer is the main aquifer that provides irrigation to the food in the central part of the United States. There's not a lot of rainfall, but when it does fall, it's held in these playa lakes, and then over time it infiltrates. So I think oh yes, here we go. So here's a little picture of the playas. They're dotted around agriculture. So again, the only diversity is in those playas. So the top image here is a profile of an aquifer recharge in a playa lake, this wetland. So the clay layer here is what's holding that bowl of water. The edges, there is going to be interacting with like a sandy unit. And so there's recharge on the edges of the playas. Where there's holes in the clay, there's recharge. And then where there's roots in these plants are areas of recharge. A lot of that water, though, is lost through these squiggly lines here is evaporation. Okay, this next image says, okay, let's take that playa and add sediment to it. So that brown layer in there is anthropogenic, induced, dumped into it sediment. What that sediment does is it decreases the holding capacity of that natural reservoir. And so there is going to be more surface area of the playa and increased evaporation and decreased infiltration. So it decreases the recharge to the Ogallala Aquifer, which is bad because the Ogallala Aquifer has a water table that has dropped many, many meters over the last 50 years. So good thing to do is to preserve these playas for that biodiversity and for the recharge of the Ogallala Aquifer. All right, let's go to the tides. These are tidal marshes. This is what we see along the coastline of North Carolina. I know there are a lot of words here, but wetlands are really important, so lots of words here. So these are protected, they protect the coastlines in middle and high latitudes worldwide. So tidal marshes are not just a North Carolina thing. They are found worldwide. On the East Coast, they're from Maine all the way down into Florida and wrap around the Gulf all the way into Texas. So the United States has lots of marshes. There's less marshes on the West Coast. There are some, but not nearly as many as the East Coast, which is kind of covered up in marshes. Some of them are freshwater, some are saltwater, some of them are brackish. So I would say most of them are brackish, that interface between salt and freshwater. There's going to be zones in the tidal marsh where there's high tide zones and low tide zones. Most of what's going to be in there are these different grasses. Spartina alterniflora is the main grass. It's smooth cordgrass. Salt rushes or juncus are in there as well. So mostly it's going to be grasses. These marshes are really important during hurricanes. They buffer the impact of storms. They can hold the storm surge, can be accommodated in these marshes. They slow shoreline erosion. They protect the coastline from erosion and from the impact of storms. And they do that nutrient thing where they absorb the phosphorus and the nitrogen from excessive fertilizers that gets absorbed in the marshes, and that decreases the amount of loss of oxygen. You hear about these dead zones in the ocean, like in the Gulf of Mexico. That comes from these excessive nutrients. And the marshes, if they can absorb those nutrients, then we decrease the amount of dead zones in our oceans. Okay, they're good. Keep them. We eat the food from the marshes, right? Who doesn't love shrimp, right? Clams, crabs, all of these begin their lives in the salt marshes. So very important for our seafood industry, and they hold pollution, those nutrients. They also are getting polluted. So we are constantly working to protect our coastal wetlands from pollution and from development. Here are the organisms, life in the salt marsh. Let me turn off my face, I suppose, and check it out. So oysters grow in the salt marsh. We eat oysters. Here's just a basic salt marsh of the East Coast, what it looks like. Sometimes there are canals that go in and out of the salt marsh. Here's the organisms of the salt marsh, and they're very important. Horseshoe crabs are super important to our pharmaceutical industry. All the way down to the meager little mumachug is a super important fish for the migratory birds. The little green herons are always exciting to see. So important to protect these coastal environments. There's a salt marsh video you can check out. It talks about the marshes. All right, other videos to watch here. This is a case study in Iowa of the prairie potholes. You should check that out. Here is about coastal wetlands in New York. And then lastly, these constructed wetlands. This is also going to be about wetlands and using wetlands to do wastewater treatment. All right.